All right, welcome back to a brand new explainer. Today, we're taking on one of the most notorious challenges in the Cambridge Mathematics 0580 syllabus. Imagine you're a mathematical detective, or honestly think of yourself as the John Wick of exam strategy. When a brutal question pushes you out of your comfort zone, you don't panic, right? You push back, with perfect, undeniable answers. Let's look at two typical students sitting this exact exam. First up, we've got Alex. Now, Alex is a hard worker, for sure, but he completely overloads his paper with raw mathematical facts. He just kind of word vomits every formula he can remember without any real analysis or structure. And then sitting next to him is Sam. Sam is quick, but she rushes. She consistently misses the critical requirements hidden right there in the command words of the question. Because of this, both of them leave behind flawed answers, just covered in those dreaded red pen marks from the examiner. Well, we're going to transform those red marks into green check marks. By the end of this session, you won't just be answering questions. You're going to be cracking the quadratic code and literally leaving the examiner no choice but to award you full marks. Let's get into it.
So, here's our game plan for today. We're going to kick things off with the missing equation mystery, then we'll follow the clues from the intercepts. After that, we'll figure out how to find the stretch factor, explore the vertex advantage, and finally, we'll open up the calculator toolkit.
Okay, part 1, the missing equation mystery.
You know, a lot of students, much like Alex, honestly believe that to find the equation of a curve, you need this massive data table of coordinates, plotting endless points until a shape finally emerges. But really, how can we determine the exact mathematical DNA of a curve from just a few isolated points? Well, think of the graph on your exam paper as a crime scene. Every single intersection, every turning point, it's all forensic evidence left behind by the function. When you see a command word like determine or find the equation, you shouldn't just start writing formulas blindly. You need a rock-solid system. So we're going to apply the Peel framework, point, evidence, explanation, link, to really structure our mathematical logic. We want to guide the examiner through our flawless logic step by step, so those top marks are absolutely guaranteed.
Now, depending on the visual clues you get on your exam paper, you're going to choose one of two primary deductive methods. On one hand, we have path A, the factorized form. You're going to take this path when your most obvious clues are the x-intercepts, which, by the way, are also known as the roots or zeros of the function. On the other hand, we have path B, the vertex form. You choose this route when your primary piece of evidence is the turning point, meaning the absolute maximum or minimum peak of that parabola. Understanding exactly which path to choose based on the command words and visual data is literally step 1 in our mathematics success blueprint. If you choose the wrong path here, you're going to waste time and risk getting totally tangled up in messy algebra. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams at Ace the Exams IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's move to section 2, clues from the intercepts. So whenever a graph crosses the x-axis, the y-coordinate is exactly 0, right? These intersection points are incredibly powerful clues. Here's a basic 3-step process if you're taking path A. Step 1, locate those x-intercepts. Let's say the curve crosses at +4 and +5. Step 2, write these intercepts into factorized brackets. Since x equals 4, your factor is x minus 4, and since x equals 5, the factor is x minus 5. Step 3, simply expand the brackets using standard algebraic multiplication, and boom, you get f of x equals x squared minus 9x plus 20. Seems incredibly straightforward, doesn't it? But watch out, because this is exactly where students like Sam get way too overconfident. They write this down, assume they've totally crushed it, and rush right to the next question. But they've just walked blindly into a massive exam trap that literally costs thousands of students their top grades every single year.
Which perfectly sets up section 3, finding the stretch factor.
Guys, paying attention here is the difference between a B grade and an A-star grade on your Cambridge exam. You see, identifying the roots only tells you where the parabola crosses the axis. It tells you absolutely nothing about how steep or how wide the curve actually is. Think about it. An infinite number of parabolas can share those exact same roots. Without finding the stretch factor, your equation is fundamentally incomplete, and the examiner is absolutely going to deduct crucial marks. Just look closely at these two equations. The first is y equals x plus 2 multiplied by x minus 5. The second is y equals 2 times x plus 2 multiplied by x minus 5. They both cross the x-axis at -2 and +5, but they are entirely different shapes. That second one is stretched parallel to the y-axis. If you don't calculate that leading coefficient, which we call a, You haven't found the specific equation of the curve on your paper. You've just found a generic family of curves.
And this brilliantly illustrates exactly how we apply our Peel framework to secure full marks. Here is the true blueprint for Path A. Step 1, your point. Always write the general form f of x equals a times x minus p times x minus q. Never ever forget the a. Step 2, your evidence and explanation. Look back at the graph and find a third, totally distinct coordinate. For example, say the graph crosses the x-axis at -2 and 5, but it also passes through the y-intercept at 0, -20. You just substitute 0 for x and -20 for y. Step 3, your link. Solve the algebra. -20 equals a times 0 plus 2 times 0 minus 5. That simplifies down to -20 equals -10a, meaning a equals 2. Then you just rewrite the final perfect equation. This systematic, calm approach is exactly how you transform a messy, panicked attempt into a flawless, examiner-friendly response.
Let's dive into Section 4, the vertex advantage.
So what happens when our little crime scene doesn't give us clear x-intercepts? Sometimes the graph just hovers above the axis, or maybe the roots are really messy decimals. In those cases, we have to adapt. If your main clue is the absolute tip of the parabola, we use the vertex. By definition, the vertex is the point at which the graph of a quadratic function is either an absolute maximum peak or an absolute minimum valley. And in math, we universally label the coordinates of this point as h, k. When a quadratic is written in the completed square form, these coordinates are practically handed to you on a silver platter. Training yourself to recognize this instantly on an exam paper is going to save you minutes of totally unnecessary calculation.
Now, just like the factorized form, the vertex form has a really strict structure you've got to follow. Step 1. Write out f of x equals a times x minus h squared plus k. Step 2. Substitute your vertex coordinates. So, if your exam paper shows a vertex at 2, 2, your equation becomes a times x minus 2 squared plus 2. Simple enough. But remember our trap from earlier? Step 3. You must substitute a third point to find that stretch factor a. Let's say the graph also passes through -1, -25. You plug those right in. -25 equals a times -1 minus 2 squared plus 2. After doing the quick algebra, you discover a equals -3. The logic here is completely identical to Path A. It's only the initial framework that changes.
So the absolute most crucial takeaway here is this explicit warning. If a can be any real number, simply knowing the vertex is completely insufficient. You always need an additional point to lock down that stretch factor. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's jump to Section 5, the calculator toolkit. Look, we've done the algebra, we've built the theories, but let's be real. Under the intense pressure of a ticking exam clock, self-doubt can totally creep in. That is exactly where your graphic display calculator, or GDC, steps in as your ultimate forensics lab. The first step in our calculator challenge is purely preparation. To access the secondary functions of your GDC, you need to press the second button, which is usually hanging out in the top left quadrant of your keypad. It sounds like a simple step, but under exam stress, students like Sam often panic and mash the wrong keys. So take a deep breath, deliberately press second, and let's prep to set the parameters of your investigation. Next up, immediately press the window key. Because you pressed second first, you are actually activating the TBL set or table setup function that's written right above the key. This right here is where we tell the calculator exactly what data we want to extract from the equation we just spent 5 minutes calculating by hand. You are literally taking control of the technology to verify your own brilliance. Now, we face a bit of a challenge. Let's call it Find the Flaw. When you're looking at your table setup screen, you absolutely must define your starting point, known as TBL start, and your increments, known as delta TBL. Think about it. If an exam question asks you to analyze a domain from -3 to +3, and you carelessly leave your TBL start at 10, you are going to waste precious time scrolling forever. Set your starting point to match the exam question's domain perfectly, and set your increments to 1 for clear whole number coordinates. Taking those 10 seconds to configure these properties properly is a true hallmark of an A-star student.
Let's keep the momentum going here.
To prevent any kind of technical confusion, go ahead and press the second button one more time to prep for the final table. Your calculator is prepped, the equation is entered, and we are literally one keystroke away from absolute certainty.
Finally, press the graph key to trigger the table function. I mean, the anticipation here is real. You spent valuable exam time decoding command words, perfectly applying the Peel framework, substituting coordinates, and hunting down that elusive stretch factor A. Now the calculator is going to compile all of that beautiful logic into a hard data set. If this table matches the graph on your exam paper, you know with 100% certainty that you have just secured every single mark for that question.
And boom, there it is. Your fully populated table of values is now proudly displayed. Look really closely at the X and Y columns. If your calculated equation was spot on, you should see the exact intercepts and coordinates provided in the original exam question reflected right there in the table. Say the question gave you an intercept at x equals -1, y equals 50, and your table confirms that? Well, your A value is indisputably correct. Having this visual verification is just the ultimate confidence booster before you turn the page to the next question.
And don't forget to use your directional pad to scroll up and down through the data. Really check out those surrounding values. Watch how the y values decrease, hit a minimum, and then start increasing again. That turning point in your data table should perfectly match the HK vertex we mapped out in Path B. By cross-referencing your calculated vertex with the GDC's generated table, you are essentially grading your own paper before the examiner even gets a chance to see it. It's a total game changer.
All right, we've reached the final system. To push your mark potential to a full 100%, you just have to follow these 3 golden rules. Rule 1, decode the clues. Read the command words carefully and choose between intercepts or the vertex. Rule 2, apply the PEL framework to structure your chosen form perfectly. Rule 3, always calculate the stretch factor A by substituting an additional point. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
I'll leave you with this final, somewhat provocative thought. We've totally mastered the parabola today. We know that cracking the code of a quadratic requires just its roots or its vertex, alongside that absolutely crucial stretch factor A. But what happens when the curve changes direction twice? What specific visual clues would we need to unravel the DNA of a higher-order function, like a cubic polynomial? The investigative logic never stops, it just evolves. Thanks so much for joining me for this explainer. Keep pushing back, and I'll see you in the next one.